Okay, so welcome back. And now what I'm going to be looking at is, in this example, I'm going to be looking at how do we decide what model to use. So this is where statistics comes in. So that's my background. So in the real world, we actually collect data and then we have to try to model that data based on analyses and based on statistics. And so we're going to do that at a very cursory level, but this is more realistic to what we do. So we collect data, and the first thing is we want to say, okay, well, what does this look like? So one of the first things we're going to do is create a graph. So let me show you the graph that they have. Okay, and then what I'm going to do is I'm going to show you how to do this on your calculator. Okay, and then we could do the exact same thing that they did on this output. Okay, so here's what they have. Okay, so they took the data, right? So there's the graph. Okay, and so that graph was created by the table that's on my board. Okay, and so now the question is what should we use, right? Well, when it comes to most of the things out there in data, well, we've got, right now that we've learned, we've got exponential, we've got logarithmic, we've got linear, and we've got logistic, right? And so how do we determine which one to use? Well, we have to look at the scatter plot. That graph that I showed you is called a scatter plot. And so that's what we created using this data. And then we have to decide, based on the scatter plot, what should we use to try to model the data. And so obviously it's not linear, right? It's obviously not a straight line, so we're not going to use linear. But it does look logistic. No, not logistic, I'm sorry. Logarithmic, right? It's got the curve like a log. It definitely is not exponential. What else? If it was logistic, now here's the thing. If you want to do logistic models, you would have to see if there's an inflection point, right? Remember where the curve starts to go from concave up to concave down, right? So it has that S curve. So if you see in the data where it kind of like has that inflection point where it changes, then maybe a logistic model would work. But in this case, I would say a logarithmic. Now, what logarithmic should we use? Well, the most common one that we find in the natural sciences is the natural log. So the first thing we would do is, looking at that data, is try to model it using something like f of x equals a times the natural log of b times x, right? Because there might be a coefficient here and a coefficient here, okay? So we got to figure out what the a and b are, okay? So let's start with the general case here with the logarithmic function and see what a and b are. Well, a couple ways we could do this. Let's use, now typically what we do in this case is we're going to use the first point and we're going to use the last point to figure out a and b, right? We need 2 points. So let's use the first one and the last one. First one's going to be easy, right? So we're going to say 1, oops, yeah, no. 0 equals a times the natural log of, well, if this is 1, if x is 1, then this is just going to be b, right? Now, we're going to safely assume that a can't be 0. It makes no sense that a would be 0. Because if a was 0, we wouldn't have a curve, okay? It would just be a constant at 0. We wouldn't have anything. So it's safe to say that a can't be 0. So in that case, the natural log of b has to equal 0 then, which would mean that b would have to equal 1. Okay, so we know what b has to be. Okay, so that means, what does that mean? It tells us that this is going to be, now we know b has to be equal to 1, right? So this implies b equals 1. So that simplifies our function to this. So now it's just going to be the natural log of x. Okay, so now we got to figure out what a is. So that's where the last point is going to come in. And so now what we're going to do is we're going to use this point here. So we're going to say 4.394 equals a times the natural log of 9. And so that means a is going to equal the natural log, oh, not the natural log, sorry. A is going to equal 4.394 divided by the natural log of 9. Okay, so now that's what a is. Okay. Now, if I stick that in my calculator, this is what I'm going to get. So I get, let's see, 4.394 divided by the natural log of 9 equals 1.999795581. Okay, so approximately 2. So I'm going to make this approximately 2, right? So I'm going to say a is approximately equal to 2. And so that means my model, so my final model for this data is going to be f of x equals 2 times the natural log of x. Now, if I take this curve and I overlay it onto the scatter plot, this is what I come up with. Or this is what they come up with. Okay. So it's not bad. I mean, it fits pretty nicely. Okay. So now you can use this to make predictions. Now that we have a model, now we can make predictions based on that model for other points that are not in our data set. Okay, and that's the power in doing these regressions. This is what we call regression. So this would be a logarithmic regression analysis. Okay, so now what if we compare this to another function? What about this function? What about that one? Then what if we compare that to the natural log of x squared? Okay, sorry about that. Now, if you graph this, you get the exact same graph. Okay? You get the same graph. Okay? So for all values of x that are positive, it's the same. The problem is when x is negative, right? Because in this case, x can be negative. The domain of this function is all real numbers. The domain of the other function, the 2 times the natural log of x, is only positive real numbers. But if you notice, this is the exact same function, right? Algebraically, right? Because all we have to do is use the power rule to bring the exponent down. But it's a big difference because that function has a mirror image to it. It has another branch, so we wouldn't want to use that, okay, because it gives more information than what our data supports. Okay. And that's it. Oh, I want to show you how to do this on the calculator. Okay, so what I did was on the calculator here, and I'll show this to you and then we'll wrap it up. So if you go under stat on your graphing calculator, if you go under stat, oops, I got to turn it on. If you go under stat and you go to edit, and if you look at the data, I put in the data in these two lists, list 1 and list 2. I put the X and the Y data in here. So now that I have the data in there, I'm going to quit out of here. So I can do second quit, and now I'm going to clear this. And now what I'm going to do is I'm going to go under stat, and I'm going to go under calc. And under this menu, if I scroll all the way down, I can get the regression I want, right? So what am I looking for? I want ln reg, right there, ln reg. So that's the natural log regression. That's what I want. So what I'm going to do is I'm going to hit enter, and now I just have to put in my X and Y data. So I'm going to do second 1 for L1, and then I'm going to put comma. So I need a comma that separates it, and I'm going to do second L2. And so now I'm telling the calculator where my data is that I want to do the linear regression on. And if I hit enter, it's going to give me my formula plus what A and B are. So in this case, it gives me something very similar. So this is going to be y equals negative 6.35 times 10 to the negative fifth. So a really small number. Okay, so it's like it's 0.0000635. Okay, negative. Okay, that's my A. Okay, so my formula is going to be f of x equals negative 0.0000635 plus 2. It's 2.00000. So 2.000 times the natural log of x, ln of x. Okay, so it's very close to what we got with the two numbers. But the best part about this is that now I can graph this. So let me do this. So if I do, if I do one more thing, let me do it again. So I forgot one thing. I can overlay this. I'm not going to show you how to do this, but I'm going to overlay this on the calculator. So if I do that, I'm going to go L1, comma, second L2, now I come with comma. Now I'm going to show you how to store this as an equation on your calculator. So I'm going to go to vars. I'm going to go to the vars, and I'm going to pick y vars. So I'm going to go over to y vars, and I'm going to hit function, the first one. So I'm just going to hit enter. And now I'm just going to hit the first one for y1. I'm going to hit enter. And now what's going to happen is it's going to store my equation that I just got. It's going to store it as y1. Now I'm going to hit enter. And now it seems like nothing happened. But now watch. Now I'm going to go to y equals, and there's my equation. Now watch what I'm going to do. I'm going to go to graph. Actually, I'm going to go to zoom, and I'm going to go to stat plot, which will automatically plot it against my data, so I don't have to worry about messing around with my window. And that's number 9, zoom stat. And now look. Okay, now if I want to plot my points, watch this. I'm going to plot my points. I'm going to go to y equals, second y equals, and I'm going to go plot. I'm going to do my scatter plot. So I'm going to hit on. Okay, so I'm going to turn it on. So I'm going to hit enter to highlight. Oh gosh, come on. Okay, so I'm going to hit on. So it's on. Now I'm going to go down and I'm going to select the scatter plot. Well, the scatter plot's already selected. So I'm going to go down. There's L1 and L2, so I don't have to change that. Those are my X list and Y list, so I got that. So I'm already done, so I don't have to do anything. So all I have to do is go to graph and watch what happens. Or excuse me, I'm going to go back to, hold on. Let me quit out of here. Okay, so I quit out of there, I got out of there, and I'm going to go to zoom, and I'm going to go down to number 9 again, zoom stat. And there it is. And see how it overlays my scatter plot. Okay, again, watch this again. Again, this is not necessarily important, but I thought it'd be cool to show you guys. So I know I took some more time, but again, pause this, go back, watch that if you want to know how to do it in the calculator, and then just practice. See you later. Bye now.